So now that we've actually got audio, I'm going to zip back through the first few slides really quickly. So my name is Floyd May. We're going to be talking about Salt, also known as SaltStack. I'm the Director of Technology for Asemio, which is a company in Tulsa that primarily deals with companies who are doing some sort of social good. That be in early childhood education, healthcare, criminal justice, that sort of thing. And so Asemio, we really just serve these organizations that are trying to make some sort of good happen in Oklahoma and nationwide. So what to expect out of this presentation? You're going to get an overview of SaltStack, what it is, how it works, how it fits together. Some network topology and security details about how SaltStack sort of fits into infrastructure, and then a skim of some high-level features. We are not going to have time to talk about all the things that Salt does because there's just too much there. Salt is very feature-rich, and we just don't have a whole lot of time. And honestly, there are a lot of features of Salt that I've never even touched. It's just big. There's a lot to it. Another thing is that we're going to be just sort of skimming through things, and so I'm probably going to move faster than you're going to be able to digest a whole lot. Really, it's just about exposure, and so it's going to feel a little bit like drinking from the fire hose, but if you do want to go back through at a slower pace and actually walk through understanding the details, getting Salt up and running, configuring systems with it, I would highly recommend. This guy has a Pluralsight course on Salt. Thank you, Ryan. So let's talk about what Salt is. It is a configuration management platform. So that means you get to inspect, read, and also control some of these things. Although this isn't exclusive, we can talk about, we can use Salt to do things like see what packages are installed, install them, uninstall them, configure user accounts, running services. We can put configuration files in place on systems, make sure that the contents of those configuration files are what we expect them to be. We can even dynamically generate elements of those configuration files, which we'll see here in a little bit. We can configure the network on those machines. We can do container management with Docker, all kinds of stuff. Really just tons and tons of things that you could potentially configure and manage with Salt. Salt is also multi-platform and actually goes to great lengths to sort of unify all of these platforms. So you can manage configuration on Linux, Windows, Mac, Unix. Salt also has some cool features for provisioning and managing cloud infrastructure. So most of your major cloud providers, as well as private cloud, you can fire away with Salt. Yeah, I need to talk about teapots, don't I? So Salt also has some features where if you really want to get nitpicky and control things like network hardware or IoT devices, there is actually a path forward for you for that as well. So let's talk about how Salt infrastructure works. So Salt has two main pieces of software. One is called the master and the other is called the Minion. Now, Salt does predate Despicable Me, but I can neither confirm nor deny that I have named minions Kevin, Papoy, and Butt. So one master, many minions. So let's talk about this communication channel between master and minions in Salt. So this communication channel by default uses 0MQ, which is a lightweight message queue, very much asynchronous. It is also encrypted using elliptic curve cryptography by default, 4096-bit RSA keys. The minion initiates the communication back to the master, which is important. We'll talk about that here in a minute. And it's also nice because that asynchronous communication channel gives us some opportunities for performance and scalability. So let's talk about this network configuration, network topology thing. If master and minions are all on the same network segment, this is really no big deal as to who initiates the communications. But when you have situations like this, where you've got, say, master and a handful of minions that are in AWS, and then you've got a handful of minions that are over on Rackspace, who initiates the communications starts to become a big deal, especially as we add more and more networks to our infrastructure. And so the minion initiating communications back to the master means you only have to expose the master once, rather than having to poke holes in firewalls in various cloud providers, data centers, etc., in order to establish connectivity between master and minions. So let's talk about performance and scalability. So Salt will scale up pretty comfortably to tens of thousands of minions, depending on how heavily you use it. And if that isn't enough, you can actually tier multiple masters and control them from a single master. So you have one master controlling other masters, which then control minions. Another nice part about the performance is that everything is asynchronous in Salt, although in general you don't get exposed to that unless you really want to be exposed to that. But the idea there being it's not really going to consume resources and block them up if it doesn't need to. Next, I want to talk about Salt's documentation. So docs.saltstack.com is the place to go for that. Their docs are incredible. One of my favorite sets of documentation for pretty much anything tech-related in general. And so I sort of put a pin anytime I see good documentation because it's kind of rare, and the Salt people do a fantastic job with it. Salt is written in Python, and so a lot of the documentation is automatically generated from the doc comments that are in the Python source code, which is also a testament to Salt doing a really good job of keeping its architecture sort of transparent. And so if you wanted to go so far as to like add some custom modules to Salt or something like that, you could very easily do that. A lot of people actually do go that route when they're managing bigger instances of infrastructure with Salt. And of course, Python, everybody knows, is better than Ruby. Please don't throw things at me. Yep, there's the boo right there. So let's talk about targeting. Targeting means identifying one or more minions for Salt configuration management operations. So let's actually go play with Salt a little bit. Is the font big enough? Can everybody see that? All right, so let's do this. Sudo, because everything does sudo, salt star test.ping. So before I hit enter, anybody have any guesses what that star is for? All minions, yes. Okay, and so test.ping, basically it's just a little diagnostic utility. Make sure that the minions are up and running and responding. And so, yay, I've got 5 minions, web 1 through 4, and then load balance 1. So let's do this. Anybody have any guesses what this is going to do? Yes, okay, fantastic. So everything but the load balancer. So this is targeting, and so this is an important element of Salt configuration management, is you want to be able to interact with specific minions. And so right now what we're doing is we're targeting based on the minion ID. And so minions IDs by default are their fully qualified domain names or their host names if you don't have an FQDN configured when you install the Minion software. So if you want to make the minion ID something different than the host name or the FQDN, you can. I wouldn't recommend it. So let's talk about other ways that you can target minions. So there you can, by default, it uses Unix file system glob patterns. You can also do minion IDs by full regex. So if you really want to go regex heavy, have fun. You can also target minions by IP address, or you can even go the route of using CIDR notation and target them using an entire subnet. So let's say you've got a /28 network and you want to do something on all of the minions inside of that /28 network, go to town. You can also target them by grains, and so let's actually talk about grains here in just a second. And you can also do a compound targeting, so if you want to mix and match, I want to target these guys by regex, and I want to target these guys by IP address, and I want to target these guys by grains. Salt actually has a domain-specific language that allows you to mix and match that and build up a nice complex targeting expression, so you can say all of these minions. So now let's talk about grains. So I'm going to just pick one server, so let's say web 1. And so if you notice the command, I did grains.items. And so this is just showing me all of the grains that are on this machine. So what are grains? Grains are data that's stored with each minion. And so by default, grains get populated based on details that are specific to that minion. However, you can also add your own data to Salt grains. And so important takeaway here is that Salt grains are data that is stored with the minion. So there are some interesting things inside of grains as we scroll back up. So for instance, BIOS release date, BIOS version, CPU flags, all kinds of stuff, network configuration, kernel, host name, all kinds of stuff. So when we talk about targeting minions, one of the nice things about using grains to target minions is if you want to target minions that have a specific operating system, grains is a great way to do that. The question was, are the grains put into a database on the minion? The answer is yes. And so let's actually see, that was web 1. So pardon me while I scroll very awkwardly here. So if you notice, one of the grains here is this grain called roles. And so this is a custom grain that I've put onto this machine because I'm doing role-based configuration management, which means I set up a role and then I say all of these machines get this role. And I do that by setting a grain called roles. And so in this particular case, this machine has a role that I've called hwas-web. And so if I wanted to target machines by grains, -g, roles, hwas-web, and then we'll just do test.ping again, I just get my web servers. So, minions and targeting. Another thing to point out here is that everything kind of goes through the salt command, and this stuff that's over here at the far right of this command, actually the second to third argument, depending on what you're doing here. This is what's called an execution module. And so when you're looking at the documentation in Salt, you're going to look for execution modules. So these execution modules are things that say, go do this stuff with these minions right now. And that is distinct from something called state modules, which we're actually going to talk about next. So Salt's configuration management ideology is basically all about declarative specifications. You tell Salt, I want this machine to be in this state, and then Salt does whatever operations it needs to bring that machine to that state. So one of the core elements of that is that Salt does a comparison between what's the desired state of the machine and what's the current state. And so that's really, really useful for a couple of reasons. Number one, it means that you've got a minimal path from where the machine is to where it needs to be. And number two, it also gives you an opportunity to do some diagnostic information. If you're making changes to your state configuration, you can test those changes and ask Salt, what changes would you make to this server if I were to apply these new states to it? And so states are put into files with the SLS file extension, and it uses YAML syntax. So let's go have a look at how that works. So first off, let's play with our load balancer. So right now I'm just going to do test.ping to make sure that my targeting is working right. Okay, great. So now I'm going to use a different execution module, command.run. And if you can see what I'm doing here, I'm going to put a superfluous comment into nginx.conf. Why am I doing that? Because we're going to now ask Salt what's going to happen when I apply states. So, some interesting things happening here. So let me scroll up here. If you notice, inside of this diff right here, because what it's doing is it's showing me a diff of nginx.conf. It's saying, hey, when I apply states to this server, I'm going to take out this superfluous comment, okay? So one of the nice things about Salt's declarative configuration management paradigm is that it allows you to really easily detect config drift. Has somebody been configuring something by hand? And then another thing, which we'll talk about in more detail in just a little bit, is that it's also saying, hey, I'm going to have to change Nginx's configuration file. That means I also need to bounce Nginx so it reloads that configuration. It's going to restart that service. I'm doing a really bad job of scrolling today. So let's go look and see what Salt configuration files actually look like for configuring states. So again, font need to be bigger. Can everybody see this? I'm seeing some shrugs. I'll make it bigger. How about that? All right, great. So I told you earlier that targeting minions is a really important part of Salt. This is another area where targeting minions is happening. So if you look on lines 2 and 3, roles : hwas-web, and then line 3 match grain. So what this is saying is that line 2 is a targeting expression that's using grains. And so what this is saying is I want to apply the state called Node.js package and the state called hwas-service to all of my minions that have the hwas-web value inside of the roles grain. Everybody tracking so far? I'm seeing some nods. I'm seeing some like, not so sure. Again, something similar, my load balancer, very same thing, targeting it by grains, and so I'm using role-based configuration management. If I wanted to, for instance, put the load balancing grain on one of my web servers, I could actually make that web server serve two purposes, one as a web server, one as a load balancer. So let's go look at the individual files themselves. So let's look at Node.js package. In this particular case, I'm doing two things inside of this file. And so this is in a file called nodejs-package.sls. And so by default, this is going to live in /serve/salt. So if you look at the very tail end of this line right here, so imagine that everything up to salt vagrant is kind of your root directory, and then serve salt Node.js package. So if we go back and forth, so we go back and forth, Node.js package. This corresponds to the file name here. And so the first thing that we're doing is we're setting up a package repository. Why? Because if you use the default Node.js package that comes with any Linux operating system, it's going to be ancient and it's not going to work right. So first things first, we've got to install the right package repository so that we get the latest and greatest version of Node.js. And so that's happening on lines 1 through 5. And so if you're familiar with YAML syntax, this should be pretty straightforward. And so the general idea here is that we're just setting up the package repo so that the package manager is going to pull Node.js from the right place. And then next, lines 7 through 11, we are actually installing the Node.js package. And so if you look at just lines 7 through 9, that's pretty much installing packages in Salt looks like that. And so the name of the package to install is by default whatever the key is on line 7, but you can actually override that package if you want to make that key work differently. And now lines 10 and 11 here, there's something really, really interesting and really, really important going on here, and that is we're saying don't install Node.js until we've configured this package repo. Now, why would we want to do that? Well, we don't want to install the old ancient version of Node.js that comes with the default I think these machines are Ubuntu machines, and it's going to install an old version. So why would I want to say don't do this until then? So what this is effectively saying is we're creating a dependency relationship between these two things, and we want to create dependency relationships between configuration items. Why? Because usually you're building up configuration a little bit at a time. This higher level config depends on some of these lower level configuration elements, and so this is known in Salt as requisites. And so within our SLS file right here, we've got requisites between elements inside of the file itself. There's also a way to specify requisites outside of those files. So let's go and look at a different SLS file. So if you notice right here, this is a different SLS file, and I say, oh, I didn't mean to delete that, I meant to highlight it. You notice it says require SLS hwas-site. And so there's also an include up here. So what this is saying is don't do anything with this particular configuration element until I've executed everything inside of this other SLS file. And so you've got two levels of dependencies that you can create here. So notice inside of these two SLS files in this diagram, I can create dependency relationships between individual items within them, but I can also create dependency relationships from within one SLS file and say, I require this other thing. And so what this allows you to do is create reusable components of configuration. Next, let's take a look at a config file. Actually, let's go look at Nginx. That's a little better. There we go. So this is an nginx.conf, but it's got some additional stuff in it, like right here and right here. So this additional stuff is getting dynamically injected into this configuration file. So let's go dig into what some of those things are. So first thing, lines, whoa. It's chilly up here and my hands are shaking. So lines 12 and 13, I'm setting up an SSL certificate. And SSL certificates are usually sensitive information, right? One would hope, anyway. So those are getting populated out of something called salt pillar. If you start to sense a theme about grains and pillars, we like these salty metaphors. So what salt pillar is a centralized data store. It's a data store that's managed by the master. By default, it's on the file system, but there are also adapters for various databases. And salt pillar is really, really cool because it is suitable for sensitive information, for secrets. And you can also do interesting things with salt pillar, like you can set different values for different minions for the same key inside of your pillar. So let's go take a look at how that works. So in this case, here is my pillar directory. And so, this is just an example file. In this particular case, this pillar called hwas-ssl. If you notice, same key, lines 12 and 13 here. The certificate path and the certificate key path, and then these are the contents here. So these are actually my SSL certs. They're self-signed, so if you copy and paste them, it's not like you're going to hack up, one of my public websites or something like that. And so what this is doing is it's configuring this SSL certificate based on that data that comes out of the pillar. Once again, there's another file inside of the pillar directory called top.sls, similar to the state directory at /serve/salt, and that tells Salt which minions get which data for their pillar database. And so in this case here, roles load balancing, lines 7 and 8, gets that hwas-ssl pillar file. So what that means is, even if, let's say you had somebody who is doing something naughty on one of the web servers and they say, hey, Salt Master, I need my SSL certificate. The Salt Master knows, no, you're not allowed to have that. Let's also take a quick look at the state file. So in this particular case, another important element of Salt is managing configuration files. So I showed you the contents of nginx.conf. And if you notice these template parameters here, lines 3 through 5, we've got all of this template-y looking stuff. And then again on lines 12, whoop, shaky hands, it's chilly. 12 and 13. So this is outside of the syntax of nginx.conf, but what we're doing is we're doing some dynamic replacement of that data. And so what the mechanism is for doing that, so line 9 here, this is saying this file at /etc/nginx/nginx.conf is a managed file. Salt is managing this file. The source of the contents of that file comes from this place identified by this URL. And so this URL is rooted at /serve/salt. And so what we're telling it is that the data comes from there and it's a template. And so line 12, template Jinja, this Jinja is the name of the templating language that Salt uses in order to do that dynamic replacement of the contents of those files. So also lines 14 and line 18, if you notice, there's also something kind of dynamic going on here. This is saying there's a file specified by this path inside of my pillar data that I also need to manage. And so we're actually grabbing the contents of those certificate files out of the pillar and stuffing them into the file system based on even the keys coming from the pillar data. Making sense so far? Okay, again, I know this is going to feel like drinking from the fire hose, just trying to get you exposed to some of the concepts. So now let's talk about something else that's really, really interesting in Salt. So if you notice right here, we have this thing called the mine, right? So show of hands, who's familiar with nginx.conf? Okay, I see some like tentative hands, I see some confident hands. Okay, so the idea here being we're configuring a load balancer, and so we have our backend servers lines 2 through 6. And if you notice, there's this for loop going on here. Because typically when you have this backend directive inside of an nginx.conf, you're saying, what are the backend servers that I'm load balancing across? And if we want to have a really dynamic environment, horizontally scalable, I want to be able to throw new web servers into this load balancing cluster easily. One of the components is I've also got to update the load balancer's configuration as I add and remove servers into that cluster. And so there's this thing in Salt called the mine. And so what the mine does is it gathers data from minions, stores them on the master, and then allows other machines to use that data out in their own elements of configuration. I'm seeing the chuckles, right? Like we love our salt metaphors, right? We've got our grains and our pillars, and now we have the salt mine. All right, so let's go look and see how the salt mine works. So here we have this key inside of another place inside of pillar called mine functions. And so the way this works is that you use pillar to expose the mined data back out to the minions. And so in this particular case, I've customized this key so that it's very, very specific. What is this for? And the mine function is network.ip adders, and then the interface parameter is eth0. And so this actually corresponds to a function that you can call on the command line. So let's actually go see what that looks like. Network.ip_adders. So salt web1 network.ip_adders interface equals eth0. Okay, so these have a one-to-one relationship. You're using the exact same modules, you're running the exact same commands. It's just in this particular case, the mine is going and grabbing that information from the minions periodically so that that information is available when you configure minions so that you can actually get this two-way data flow. So dynamically adding new minions, we can update our load balancer configuration. So one of the nice things about that is I don't have to care about the IP addresses. So in this particular case, all of my minions and my master are running on Vagrant. I went ahead and just said, just let it do DHCP. I don't have to care about the IP addresses. Salt will figure it out for me. So now, let's talk about orchestration. So we can configure a server using Salt, and we can configure that server in a well-defined order. We can specify requisites so that we can make sure that this configuration element happens before this one happens, before this one happens. In addition, there's one other little tidbit of information that we talked about, but we kind of glossed over, and that is this. So the only thing that Salt noticed when we added that superfluous comment to the load balancers nginx.conf, the only thing that really has changed on that system is that we have extra stuff inside of nginx.conf that needs to be gotten rid of. However, Salt also says, I need to restart this service whenever nginx.conf changes. Let's see how that works. Right here, inside of nginx, we say package.installed. Okay, we need the nginx package installed. And we also are saying the nginx service needs to be running. And the service.running state module also has some parameters for watching things. And so what this is saying is this service needs to be running, and I want you to watch for changes in these files. So if Salt reconfigures any of the contents of any of these files, this service needs to be restarted. So now I'm actually going to apply state on load balance 1. And so let's talk about applying states before we move on to orchestration, because I think this is a really important element of Salt, and one of the things that I really, really love about it. Salt does a good job of telling you what it's doing and what it's done. So font's kind of big, so it's a little tough to see, but one of the most important things when you change configuration with Salt is it gives you this report at the very end. Here's a summary for this minion, load balance 1. I succeeded in applying 5 states. I only changed 2 of them, though, and none of them failed. And so we can go back and look and see what has changed. Question?
Yeah. So with the, like I have to restart the service and I make changes to these files, how does that work if you have a dependency tree set up where I need this service to be on this machine and then restart it to be able to install this other service on this machine and configure it properly? Is there a way to, in the syntax, to find a dependency tree that allows you to handle that elegantly?
Okay, let me restate your question so I make sure I understand it, because that was a very nuanced question. Is it possible to create dependencies between services so that if I reconfigure one service, this other service also needs to be restarted? Is that your question?
Yeah, or I need this, if I want to add this service to this machine in a declared way,
Mm-hmm.
this other service needs to be restarted first before I can do it. Like, let's say I've got a whole configuration of the server I'm doing, and I need Java installed and some other thing that depends on Java installed, and I need that to be restarted before I can install this. How does it handle that?
That's okay. So let me again restate the question. So let's say I need to add a service to a machine. I've already got existing services that are present on the machine. In order to add this new service, I've got to potentially restart this other service that's already there, maybe bring it down, install this other service, then bring this one back up. Is that possible within Salt? And the answer is yes. There are a number of different techniques for doing that. We probably don't have time to dig into them, but maybe we can talk afterwards. One of the cool things that Salt does allow you to do is you can have one-time commands that you can run, or commands that only run in certain scenarios. So only run this command if installing a package happens for this particular package, for instance. And so lots of different ways to skin that cat, actually. So let's talk about orchestration. So we can do configuration within a specific machine. We can do it in the right order. We can, bring services down, install users, so on, so on, so on. But that usually isn't enough for managing infrastructure. You usually are going to need to coordinate configuration changes across multiple minions in a specific sequence. That's what orchestration is for. And that orchestration also uses the very same syntax for doing requisites, creating those dependency relationships as Salt states. So let's talk about orchestration. So for my configuration that I have here, I've got a load balancer that farms out web requests to a handful of web servers. And so I have an orchestration that allows me to bring a new web server online. And so the idea there being, I'm going to identify which minion that I want to bring online and put into the cluster. And so what that orchestration is going to do is it's going to say, okay, I need to apply the web server role to that minion. I need to configure that minion. And then I need to make sure that the mine functions have run so that that minion reports its IP address back to the master, so that then I can reconfigure the load balancer to include that new web server's IP address, so that now the load balancer has that new web server in its configuration, and it's going to farm out web requests to it. So all of those things have to happen in the right sequence, or this ain't going to work. I also have another orchestration. We'll walk through both of them real briefly. It's 15 after, so I want to make sure we leave time for Q&A. We also have a rolling upgrade. So we have a handful of web servers, and let's say we've got a new version of the website that's running on these web servers that we need to roll out. So we don't want to take them all offline to do the upgrade and then bring them all back on. We don't want downtime. We also don't want 2 different versions of the website potentially running at the same time, and so web request 1 gets the old version, web request 2 gets the new version, web request 3 gets the old version again. That's not good. So we're going to do a rolling upgrade, take half of them offline and upgrade them, swap the load balancer config to now point at the newly upgraded servers while we upgrade the remaining half of the web servers, and then finally bring the remaining half back online again. So let's talk through the easy one first. So if you notice here, I have this folder called Orc, or Orch, depending on how you want to pronounce it. So inside of here, I've got my two orchestrations. One is called New Web Server. So line 1, set new minion role. We talked through this. We're going to append the hwas-web role to the roles grain, and we're going to target it based on the target minion that we identify when we actually run this orchestration. Then, this one, apply states on new minion. By the way, if you're doing orchestrations, name them well so it's clear what's going on. And so we're going to say this SLS file, HWAS service, because my website is called HWAS, it's Hello World as a Service. And notice this require, I have to make sure that that role has been set first. And so this is sequencing. Sequencing is really, really, really important in orchestrations because by default, orchestrations will attempt to do these things in parallel, especially if it talks to multiple minions. And so it's really, really, really important to make sure that you've got your requisites set up properly. Then we're going to refresh pillar data on that target minion. That way that minion knows, hey, I've got a mine function that I need to report back to the master. We're going to update the mine data back to the master. We're also going to set this online grain. So this is an element of the rolling upgrade that we're going to talk about in a minute. So one of them is, so one of the grains, the role just says this is a web server. I've also got another grain. So again, grains are machine specific. I've got another grain that identifies whether or not this machine actually needs to be in the load balancer config right now. If it's not there, then we take it out of the load balancer config. And so this is what we use to make sure that only the ones that are online are in the load balancer config, so we can take some offline in order to do stuff with them, upgrade them, so on and so forth. And so then we've put it into the online group, and then we run state apply on the load balancer, which is then going to go and grab all of those IP addresses, put them into Nginx configuration file, restart Nginx, and so now it's farming out to all of the web servers. Making sense so far? I'm seeing some nods. I'm seeing some not so sures. Okay, so the question was, earlier I said that it was the minions that initiated communication. So how does that work where it's the master telling minions what to do? And so really this is, it's two levels of abstraction. The minions initiating the communication is really just about establishing the communication channel. It really doesn't have anything to do with which machine is initiating commands to run. It's just a network configuration. Yes. Yes, the comment was the communication channel stays open. The answer to that question is yes. So the minion initiates the opening of the communication channel, and so in general what that means is you're going to reach out, the minion will reach out to the master, establish the communication channel, and so now that communication channel is open so the master can send commands to the minion. The question was, so they're not polling. Not necessarily polling, but it's basically just the establishment of that 0MQ communication channel. And so 0MQ is pretty slick in the way that it optimizes network communications. So there probably is a polling element to it, but it's not like it's not a miserable like, oh my gosh, look at all of this network traffic that's going back and forth. So hopefully that answers those questions. Are we brave enough to go look at the rolling upgrade orchestration? I see one thumbs up. I see, okay, all right, let's go. Okay, so, all right, so this one's fun. So step one is I need to get the Minion IDs that are all in the load balancer config right now. And then what I'm going to do is I'm going to divide them up into two groups, the primary group and the secondary group, right? So the first step in the orchestration is I'm going to remove the online, the HWAS online grain from the primary group. Step two, so line 7 here. So I'm going to remove that grain from the primary group. So I'm saying, for this primary group, I'm going to say, you guys are no longer online. Step two is I'm going to tell the load balancer, go ahead and take these things now that they're offline out of your config. So quit routing HTTP requests to them. Step three is I'm going to upgrade that primary group. I'm going to go ahead and refresh the state on those groups, which ultimately increments the version of software that's installed on them. Then I'm going to bring those primary machines back online. I'm going to take the secondary group offline, switch the load balancer so that it's now pointing to the primary group, upgrade the secondary group, reset the grain back on the secondary group to indicate that they should be online again, and then finally tell the load balancer, okay, bring everybody back online. This is a 9-step process, but if you notice, there are requisites at every step in the process, and so this sort of intricate, complex dance to do this rolling upgrade, Salt does a fantastic job of making sure it all happens in the right order. If anything goes wrong, it stops and tells you, okay, this happened on this machine, this is why. And ultimately, this orchestration helps you keep all of these details organized without having to do this rolling upgrade by hand. So with that, let's kind of go back through some of the areas that we covered. So we covered what the network topology of Salt managed infrastructure looks like. We saw running commands on Minions looks like. We've learned about states, we've talked about pillar, we've talked about grains, we've talked about the salt mine, and we've talked about orchestration. I know, again, drinking from the fire hose, this is a really brief skim, and there's a lot of information to sort of absorb about Salt, but hopefully this was at least a good overview of what you can do with Salt. And so with that, anybody have any more questions? The question was, what about rolling back? Well, that's a great question. So this is DevOps OKC, and so that kind of leans more into the dev side of that as well. So in this particular case, rolling back could potentially be indicating whatever Git branch that your website's source code is tracking against. Perhaps you could just yeah, potentially. And as a matter of fact, I'll actually show you how this works. So in my particular case, I am tracking against the master branch for this particular Git repository. Now, Clayton, you'd asked a question a little while ago about how do I handle complex orchestration scenario or complex scenarios where I've got to stop this service or I've got to do something with this service before or after I install this other thing. And so this is an example of what happens when you do that. So this command.wait, what this is saying is, I want you to run this command in this directory, but only if something happens with my source code. So I'm not running npm install every time I touch this minion. I'm only going to run npm install if the source code specified by this state up here on line 13 changes. Make sense? So back to the earlier question, as far as, well, what if you want to roll back? Yeah, you could just have somebody push a commit to your GitHub repository and then just do the upgrade again. That, of course, assumes that all the developers have done a good job of making that part of it work properly, and you also have to think about things like database migrations if you have databases involved. Yes, nothing is ever simple as it. All right, more questions. Would it be helpful to look at this list, by the way? Another question. So the question is, Clayton said, most of my experience is with Chef, and Chef has cookbooks, and you can version cookbooks. Am I understanding that correctly? And so then you can specify what version of the cookbook you want to use for a particular machine that's being managed by Chef. Can you do that with Salt? The answer is, I don't know. More questions? The comment was, I have a bunch, but I don't feel like sharing them all right now. Yes?
Have you experienced this using Salt in a mixed environment? So I have a Linux and Windows hybrid environment, like a lot of people do, and nice to use one tool.
So the question is, do you have experience using Salt in a mixed Windows Linux environment, and what's been the experience? I have used Salt in a mixed environment, and it was okay. Windows is usually the oddball, right? Linux and even Mac to some degree you can kind of manage similarly, but Windows is where things kind of start to come apart, especially when you start thinking about things like installing packages, because Windows doesn't have a package manager. And so there are some interesting things that you can do to sort of hide that thing away. But there are also some things that you can do with Salt, so that if you say you have to do something completely different for Windows than you do for this other type of machine, you can do that, and you can actually even embed that into a single SLS file, which can be really, really handy. So you've got one SLS file, regardless of which type of machine it is. You can still say, I want this machine to install everything inside of this SLS file, and that one sort of self-contained module of config can abstract away all of the details of, if it's Windows, I got to do this, otherwise if it's Linux, I got to do that. And then you can use that as a building block to sort of abstract away some of the operating system specific details. Hopefully that answers your question.
I was actually digging through on the Salt documentation. It has a module called Chocolatey, which integrates with the Windows Chocolatey package manager. So if you have Chocolatey on that machine, which you can get with Salt, then you can use Chocolatey for managing Windows packages.
So the comment was, you can actually use Salt to use the Chocolatey package manager for Windows to do package installations. I'm not sure if I've used that or not, but I think I have, and it works. It works. One of the things that you will run into with just managing a mixed environment where you've got different operating systems, different flavors of Linux, Windows, is that packages will have different names in different package repositories. And so in Debian it's this, in Red Hat it's that, in Windows it's this, and there are some details of the configuration management that you do in Salt that will kind of make it easier for you to hide those things away. And so one of the things that's nice about it is that you get these two layers of configuration where an SLS file is sort of self-contained, and within that SLS file you can sort of work out the details. So like we saw with Nginx, for instance. And so obviously installing a package repository on Windows isn't going to work. So you're going to have to go through a completely different technique if you wanted to install Nginx on Windows. But you can still embed that all in the same SLS file. And then regardless of whether or not you want Nginx on Windows or Nginx on Linux or Nginx on macOS, you can build one state file that's sort of reusable across all of those things. Because, so for instance, like you want to do Node.js or something like that, you want to do something with Node.js. For the most part, that experience is going to be pretty similar from one OS to the other, and so you can manage that more or less cross-platform, but you still have some of those platform-specific details. And so I really feel like Salt does a good job of making it easy for you to deal with those cross-platform inconsistencies. Cool. All right. Thank you. Thanks for having me.